Good afternoon. We are going to start solving systems of linear equations. We already know different techniques. If you want to pause a second and try to remember what techniques did we use to solve system of linear equations, okay? You will remember that we used the substitution method, the elimination method. You can also graph the equation. But also, everything we've been doing about matrices right now is leading to this lesson on how to solve system of linear equations using matrices. Now, I'm going to start by the very, very basic. I think I'll have to do 2 or 3 different videos to explain the different parts of the solving the equation, okay? So we will start with something extremely simple, but the word itself probably is confusing to you, but I will explain it and it will make a lot of sense. Okay. A matrix identity. What does the word identity mean? Well, I'm going to bring it to a lower scale so it makes more sense to you. If I'm giving you the number 10 right now, and I'm asking you to multiply it by a number, by something, that will not alter the value of your original value of your 10. What is it? Simple, right? 1. So 10 times 1 equals 10. So 1 is the multiplication identity. It means it's multiplying by a value that does not change the value of my original input. Okay. Now, if you think about addition, what do you think the addition identity is? Right? Again, what do I add to positive 10 in order to not change anything? You got it. 0. 0 is the addition or subtraction, right? And by the way, the multiplication identity is also the division, right? Dividing by 1 does not change the original value that we input. Okay. So now in the world, so we don't really talk about that because this is something that's very implied, the word identity. But when you get to the world of matrices, you need to know what an identity is in order to be able to solve your equation. This is going to be one of the steps of solving your linear equations. Okay, that's what I'm saying. You'll see it may be confusing right now. Why is it that I need to know that? Well, it will be part of the solving process. Okay, that's why you need to know it. Quickly, now I need to know something in a matrix that I can multiply this original matrix by that will give me the exact same thing. A lot of you will be tempted to say, and I know that right now, if you pause and you try, even if you try to do it with 1, 1, 1, 1, okay, let's see if it works. Okay, 1, 1, 1, 1 does not work, but check it out. This is a 2 by 2, and this is a 2 by 2. Can I multiply? Yes, because my inner values are exactly the same. So before I start, don't forget to always verify that. But the identity matrix will always be the same size as the matrix you're trying to cancel. By the way, 2 things. Your identity matrix will always be, I'll erase that after because I'll need place, always same size, same dimensions, right, of original matrix, right? Original matrix, and always a perfect square. What do we mean by a perfect square? Perfect square, perfect. Meaning a 2 by 2, a 3 by 3, a 4 by 4, a 5 by 5. Okay, this is always going to happen when you are trying to find a matrix identity. There's a reason why, again, I'll explain a little bit later, but when you solve a system of equation, if you have 2 variables, you need 2 equations. If you have 3 variables, you need 3 equations, and so on. Okay? Now, I will, okay, so let's start checking our wild guess of 1, 1, 1, 1 and see quickly if it works. So remember, 4 times 1 equals 4 plus 7. Here, remember, it's 7 times 1. Negative 7 times 1 equals negative 7. So if I add those two, if I had 4 plus negative 7, I get negative 3. Do I get 4? No, I don't. Okay, so I know this combo that I put in there doesn't work. But look what happens here. I really want to bring your attention to this. Check it out. If I was going to do just 4 times 1 here, damn it. Sorry, I clicked too much. Okay, so if I was going to do just the 4 times 1 here, right, the first one, this times this, I would get my first answer. So what do you think this value could be here, this one here, that would make the negative 7 cancel? Because we just would like to eliminate this one, maybe. Think about it. Maybe we can try it with a 0. Let me just check it out. So if I'm recopying this right now, negative 7, 3, and 1, multiply by a 1 and a 0 here. Let's check it out. What is 4 times 1? 4. And what is negative 7 times 0? 0. You see, I get my first entry that hasn't been altered. So it actually works. Okay. Now, I want my second entry to be negative 7 here. So again, in this case, if I have a 1 and a 1 here, it's not going to work because I would do 4 times 1 and negative 7 times 1. And again, I'm running into the exact same problem. So how do you think we can use this same train of thought we talked about before? We can actually but reverse the roles. We can put a 0 here and maybe a 1 here. Let's see if it works. Now you would do 4 times 0, which will be 0, plus negative 7 times 1, which is negative 7. And we get 0 plus negative 7, negative 7. Now let's just quickly check if it works with our second row of a first matrix. So we're going to do, what is 3? I'm going to use a different color. What is 3 times 1? It's 3 plus, what is 1 times 0? 0. So we get 3. You see, we're getting the exact same value that we had originally. And let's try our last one. We're going to do 3 times 0. 3 times 0 is 3. Sorry, I'm just going to erase this. It's 0. 3 times 0. And then 1 times 1 is 1. And so we get a value of 1 here. Okay, so look what just happened. We had our original equation. We multiplied it by the identity matrix, which would be 1, 0, 0, 1. And we went back to the original value. So I'm going to turn the page to make it a 2 by 2 identity matrix. Matrix is, so what does it mean? Again, it just means that if I multiply 10 by 1, I get to 10. Well, if I multiply a matrix by this value here, 2 by 2 matrix by this, I go back to the original matrix. Like in the world of 2 by 2 matrices, this matrix is like the 1 in the world of multiplication. Okay, so remember that. In the 3 by 3 matrix, you will not really have to use that, but I want to show you anyways. It would look like this: 1, 0, 0, 0, 1, 0, and 0, 0, 1. Okay, if you'd have a 3 by 3 matrix, try to multiply a 3 by 3 matrix by the identity matrix, you will go back to the original. Okay. So remember this, it is super important. You will need this. This identity matrix will be part of the process of solving an equation. We're going to be doing this in the next video.